There's a planet where it rains glass sideways at 5,400 miles per hour, where the sky glows blue on one side and pitch black on the other. The planet experiences temperature swings from molten lava to absolute zero in a matter of miles. HD189733b defies all the established rules of planetary science that we previously understood. It's a world of eternal storms, liquid metal clouds, and winds that could shred diamonds. What we've discovered about this alien nightmare might rewrite everything we understand about planetary formation, weather, and the violent extremes of space. This is HD189733b, the planet that shouldn't exist. And what you're about to see will haunt your dreams. At first glance, HD189733b looks deceptively beautiful from space. From a distance, HD189733b appears as a brilliant azure marble floating in the cosmic void, reminiscent of our own Earth. But don't let that stunning blue fool you. This isn't water reflecting sunlight. The reality is something far more sinister. This is a hellscape masquerading as a paradise, where the stunning blue hue originates from clouds of molten glass particles suspended in an atmosphere traveling at hypersonic speeds. Located 64 light-years away in the constellation Vulpula, this gas giant is what astronomers call a hot Jupiter, a massive planet orbiting so close to its star that 1 year lasts just 2.2 Earth days. But calling it hot is like calling a nuclear explosion warm. Surface temperatures reach 1,000 degrees Celsius on the cooler side and spike to over 1,200 degrees where the star's radiation hits directly. So how can this distant world burn so brightly with heat? To answer this question, we must abandon all our previous assumptions about planets. HD189733b is not your typical gas giant. It's the most atmospherically violent object we've ever discovered. It is a place so extreme and unpredictable that even NASA scientists have called it the most tortured atmosphere in space. Today, we'll uncover the apocalyptic forces that created this atmospheric monster. We will explore the reasons behind its behavior, which is more akin to a cosmic hurricane than a planet, and how this world, defying conventional wisdom, could potentially provide insights into the most extreme weather systems in the universe. But be warned, the deeper we go into HD189733b's atmosphere, the more it reveals just how violent and alien our universe truly is. Imagine a planet locked in eternal torment. HD189733b orbits its star so closely, just 2.9 million miles away, that it's tidally locked, its same face always pointing at its blazing host. One side permanently faces the furnace, while the other is trapped in endless night. The day side is a molten wasteland, where silicate particles vaporize into glass droplets. The night side is a frozen desert, where those same particles crystallize into razor-sharp shards. But here's where things start to become apocalyptic. The temperature difference between these two sides creates the most violent weather system ever discovered. The day side reaches 1,200 degrees, while the night side plummets to 500 degrees. This massive thermal gradient doesn't just create wind, it creates atmospheric warfare. Winds race around the planet at 5,400 km/h. That's 7 times faster than the speed of sound on Earth. These aren't gentle breezes. They're atmospheric tsunamis carrying clouds of molten glass from the day side to the night side in a never-ending cycle of destruction. It's like taking a blowtorch and a freezer and forcing them to fight for eternity. Only this stuff isn't metal. It's an entire planet's atmosphere. And an atmosphere under this kind of pressure does something extraordinary. It weaponizes itself. HD189733b, this unassuming blue dot, is boiling and freezing simultaneously, twisted by thermal forces so extreme its very weather patterns are pushed beyond the limits of physics. But the real chaos isn't hidden beneath clouds. The chaos pours down from these clouds. What follows is more violent, strange, and spectacular than anything else in the universe. HD189733b doesn't just have severe weather, it's a planetary storm system. While Earth has hurricanes that last days or weeks, HD189733b has been locked in the same hypersonic storm for billions of years. But here's the true anomaly. Unlike Earth, where weather is driven by water evaporation and condensation, this planet's entire atmospheric system is powered by something else entirely: glass precipitation. Remember those temperature extremes between day and night? That relentless thermal gradient generates more than just wind. It creates a continuous cycle of glass formation and destruction. Silicate particles on the day side don't just become hot. They melt, vaporize, and get swept up into the atmosphere as microscopic droplets of liquid glass. This process creates not just pockets of heat, but rivers of molten particles streaming through the upper atmosphere. Weather systems on HD189733b aren't minor. Some storm fronts stretch across thousands of kilometers, carrying glass clouds that rain sideways at hypersonic speeds. The precipitation doesn't fall down. It is blasted horizontally by winds so powerful they could strip the paint off a spacecraft in seconds. And the temperatures? These glass storms can maintain 1,000 degrees even on the night side, heated by friction alone. Scientists believe some of this atmospheric glass may be composed of materials similar to what we use in fiber optics. In other words, it's possible that HD189733b is influencing the development of our technology. Spectroscopic analysis on Earth can detect the power of its storms. As the planet passes in front of its host star, it causes shifts in starlight that reveal the chemical signature of an atmosphere in constant, violent motion. But HD189733b isn't just stormy, it's alive in the most destructive sense imaginable. The most amazing part is that we've only begun to explore the storm's colors, which tell a story as odd as the weather. Take one look at HD189733b through a telescope and you'll think you're seeing Earth's twin. That brilliant azure blue seems almost inviting, like a cosmic ocean world waiting to be explored. But this star isn't water. This is deception on a planetary scale. HD189733b's surface is painted in the most beautiful lie in the universe. The blue color comes from silicate particles, essentially microscopic glass beads, suspended in hydrogen and helium. These particles don't just float peacefully. They're in constant motion, heated, cooled, melted, and crystallized in an endless cycle of atmospheric violence. The blue hue is created by Rayleigh scattering, the same process that makes Earth's sky blue, but amplified and weaponized. The glass particles scatter blue light more efficiently than other wavelengths, creating that deceptively beautiful azure glow. But unlike Earth's gentle atmospheric scattering, this is scattering at 5,400 mph. Simultaneously, the planet experiences a blast of cosmic buckshot from the same particles that create that gorgeous color. The day side glows with the intense blue of superheated glass vapor. The night side shows deeper, darker blues where those same particles have crystallized into solid shards. And the Terminator line, the boundary between day and night, creates a gradient of blues that shifts and changes as the glass transitions between liquid and solid states. This radiation doesn't just hit HD189733b, it transforms it. The star's intense energy breaks molecular bonds, ionizes particles, and helps maintain that thin but violent atmosphere. It's not enough for breathing, not enough for gentle weather, but just enough to create the most spectacular and deadly light show in the known universe. The result is a planet that doesn't look like a gas giant at all, but rather an alien marble painted by fire, ice, and the invisible hand of stellar radiation itself. The colors of HD189733b aren't just beautiful, they're warnings. These warnings reveal the molecular dynamics of a world so violent that even its beauty can be lethal. Let's start with Silica, the star of this atmospheric horror show. On Earth, we discover it in sand, glass, and computer chips. But on HD189733b, it's everywhere, suspended in the atmosphere like a permanent dust storm made of microscopic glass beads. These particles come in different phases, depending on temperature and pressure. At 500 degrees, they crystallize into solid shards. But increase the temperature to 1000 to 200 degrees, add stellar radiation, and suddenly you observe liquid droplets forming and reforming in real time. Then there's the hydrogen and helium-based atmosphere, gases that should be relatively calm on most planets. But on HD189733b, they're supercharged, moving at hypersonic speeds, carrying their deadly glass cargo around the planet in a never-ending atmospheric conveyor belt of destruction. And it doesn't end there. During the most intense heating cycles, the stellar radiation doesn't just warm the atmosphere, it ionizes it, creating charged particles that interact with the planet's magnetic field. This creates auroras, but not the gentle northern lights we see on Earth. These are violent electromagnetic storms that stretch across entire hemispheres. This mix of chemistry and chaos has created an atmosphere in constant transformation, a living laboratory for extreme planetary science. But HD189733b doesn't just look different. Its weather behaves differently too. And what you're about to see next might just be the most alien atmospheric system in the entire galaxy. On Earth, weather systems are often predictable. Storms form, move, and dissipate. On HD189733b, forget everything you know. This planet doesn't have weather. It is weather. HD189733b's atmospheric systems are chaotic, global, and alien. The entire planet is essentially one massive storm system, like a hurricane the size of Jupiter that never ends. Its winds don't change direction seasonally. They've been blowing in the same hypersonic pattern for billions of years. The day side acts like a massive heating element, constantly vaporizing glass particles and launching them into the upper atmosphere. The night side functions as a cosmic freezer, crystallizing those same particles and sending them crashing back toward the surface. But with 5400 MPH winds, nothing stays where it lands. These glass particle flows create vast atmospheric rivers of molten and solid material that stretch around the entire planet. Unlike Earth's jet streams, which are relatively narrow bands of fast-moving air, HD189733b's atmospheric currents are planet-wide conveyor belts of destruction. What's missing? Seasonal variation. You won't find changing weather patterns here. Instead, the same apocalyptic storm has been raging since the planet formed. Some regions experience constant glass precipitation, others face endless glass particle sandstorms that could strip metal from spacecraft. And don't let the consistent blue color fool you. The violence is still there. Atmospheric pressure waves travel around the planet like sonic booms, each one carrying enough energy to power entire civilizations. Each wind current on HD189733b is its ecosystem of destruction, its pressure system, its own hypersonic nightmare, and together they form a world in constant atmospheric motion. But not all features on HD189733b are born of wind and glass. Some are shaped by something deeper, stranger forces that come from the planet's relationship with its star. Amid the rivers of glass, storms of particles, and hypersonic winds, something unexpected happens. Atmospheric tides, massive bulges in the planet's atmosphere that rise and fall like cosmic breathing. The star's intense gravity and radiation push and pull these gravitational waves, known as thermal tides, to stretch thousands of kilometers high in the atmosphere. These aren't gentle atmospheric movements. They're planetary-scale pressure waves that compress and expand the entire weather system in rhythmic cycles. There's no gradual change, no gentle transition. The atmosphere bulges toward the star, creating a massive high-pressure zone, then snaps back, sending shock waves around the entire planet. But how does an atmospheric tide like this even form on a world that's constantly being blasted by stellar radiation? The answer may lie in HD189733b's unique orbital mechanics. Unlike Earth, where tidal forces from the Moon create gentle ocean tides, this planet experiences tidal forces from its star that are millions of times stronger. The star's gravity doesn't just pull on the planet's solid core, it pulls on the entire atmosphere, stretching it, compressing it, and reshaping it in real time. This is not weather. Gravity itself is physically molding the planet's atmosphere. And these atmospheric tides aren't isolated events. Across HD189733b, scientists have detected dozens of similar pressure waves, many sharp, violent, and accompanied by massive temperature spikes. They're not storms. They're gravitational sculptures. They provide evidence that stellar forces, even in a world of glass and wind, have the power to reshape entire atmospheres like clay. But what's happening during these tidal events may be even more shocking. For decades, scientists believed that hot Jupiters like HD189733b were simple, uniform gas balls. But now, that theory is being completely rewritten. For years, scientists believed HD189733b's extreme weather could only mean one thing: a uniform, well-mixed atmosphere where heat and materials circulated evenly around the planet. It made sense. How else could such violent winds maintain consistent patterns for billions of years? But recent spectroscopic data from the Hubble and Spitzer space telescopes is rewriting that theory, observation by observation. These telescopes don't just take pictures. They analyze the light passing through HD189733b's atmosphere as it transits in front of its star, revealing the chemical composition and temperature structure in unprecedented detail. And the data shows something more complex and more fascinating than anyone expected. Instead of a uniform atmosphere, HD189733 seems to have distinct atmospheric layers, zones of different temperatures, pressures, and chemical compositions stacked on top of each other like a cosmic layer cake. Each layer moves at different speeds, creates different weather patterns, and responds differently to stellar heating. The upper atmosphere races around the planet at maximum speed, carrying the lightest glass particles. The middle layers move more slowly, dense with heavier silicate materials. The lower atmosphere, closest to the planet's core, may be moving in entirely different patterns, possibly even in the opposite direction. Think of HD189733b like a planetary-sized atmospheric engine with different gears spinning at different speeds. This explains why some spectroscopic observations show different wind speeds and why the planet's thermal emissions vary in ways that don't match simple atmospheric models. And perhaps even more surprising, HD189733b's atmosphere is likely much more dynamic than we once imagined. Not just a static storm system, but a constantly evolving, multi-layered atmospheric machine powered by stellar radiation itself. What we're seeing in our telescopes isn't random. It's the outward expression of a world whose atmosphere is in constant three-dimensional rearrangement. The meteorological symphony is driven by gravity, heat, and the intense dance between planet and star. But how do we even know these facts with such clarity? That takes us to the space telescopes that made it all possible. When NASA launched the Hubble Space Telescope in 1990, its mission was to observe distant galaxies, nebulae, and the deep structure of the universe. But no one expected Hubble to become one of the most important observers of exoplanet atmospheres. Combined with the Spitzer Space Telescope and ground-based observatories, these instruments began detecting something extraordinary: the chemical signatures of alien worlds. As HD189733b passes in front of its star every 2.2 days, it creates what astronomers call a transit. During these transits, starlight passes through the planet's atmosphere, and different molecules absorb different wavelengths of light. By analyzing this absorbed light, scientists can determine what's in the atmosphere, how hot it is, and how fast it's moving. And what they revealed was breathtaking. Despite temperatures hot enough to melt copper, scientists found water vapor in the upper atmosphere. The lower layers contained methane and carbon monoxide. Most shocking of all is the direct evidence of 5,400 mph winds obtained through Doppler shift measurements. Scientists could track atmospheric circulation in real time, watching hot spots move around the planet as the gas-laden atmosphere carried heat from day side to night side. They detected temperature variations, pressure changes, and even seasonal atmospheric variations as the planet's elliptical orbit brought it slightly closer and farther from its star. Then, unexpected discoveries emerged: proof of atmospheric escape, a phenomenon in which stellar radiation is literally removing the most energetic particles from the atmosphere. HD189733b is slowly losing its atmosphere to space, creating a comet-like tail of escaping gas and particles. What these telescopes gave us wasn't just data. They gave us motion, change, proof that HD189733b is evolving before our eyes, and perhaps a glimpse into what thousands of other hot Jupiters throughout the galaxy might reveal about the violent extremes of planetary atmospheres. HD189733b is chaotic and frozen in motion. HD189733e is a place where gravity transforms into wind, where chemistry simultaneously creates beauty and death, and where science is still catching up to the atmospheric violence unfolding in its skies. It's more than just a planet. It's a living reminder that the universe doesn't follow our rules. It writes its own. And if a world like HD189733b can exist, what else is out there waiting to be discovered, burning, freezing, breaking the laws of atmospheric physics? Well, speaking of impossible objects, The science behind rogue planets will make HD189733b look like a gentle breeze compared to a cosmic hurricane. So, if you're ready to have your mind truly melted, click on this next video. The science behind planets that wander through space without stars will break your brain. Trust me, what you'll learn there will change the way you see planetary formation forever.